We are now going to look at grouped frequency distributions. So we had qualitative data, single value groupings, and now grouped frequency distributions. And this first one is going to be for discrete data. So discrete data is like when you're counting, and then continuous data is for when you're measuring. And so we'll do another one for continuous data. But in this video, let's look at the discrete data. Here we have the number of home runs hit by Babe Ruth each year of his 15-year career. And you can see here that the minimum is 22 years, and then the maximum is his record-breaking 60 home runs that he got in 1 year. So if we go from 22 to 60, that range is way too large in order to do a single value grouping. We'd have like 40 classes or something like that. So what I'm going to do is I'm going to do a grouped frequency distribution. And now there's not a right or wrong way for dividing up the classes. There are different methods. One reason I like this data is because since it goes from 20 to 60, it works really well to do 20s, 30s, 40s, 50s, 60s. And that's just a real nice, natural way of dividing the data. So that is what I'm going to do for this one. So I'm going to make my table. I get number of home runs and then frequencies. Okay, so I'm going to, like I said, I'm going to do 20s. So 20 to 29, 30 to 39, 40 to 49, 50 to 59, 60 to 69. Okay, and now each one of these values will belong in one and only one class. And one nice thing about dividing it up in such a natural way, it's easy to count out the number of observations in each class. I just have to look for all the 20s. So there's 1, and that's 2. So there's 2 20s. And the 30s, there's 1 and 2, so 2 30s. And then 40s, 1, 2, 3, 4, 5, 6, 7. Looks like there's 7. And then we got the 50s, so 1, 2, 3. So that looks like there's 3. And then I think in the 60s there's just that one record-breaking year, 60 home runs. So now to make sure I didn't miss any, what we're going to do is we're going to add up the frequencies, and that should equal 15 because that's how many observations there are in the data set. So there's 10, 15, and that checks. So we're good. Okay. So this would be the frequency distribution table. So now let's make the histogram. Let's see here. What I'm going to do is I'm going to put the lower limits along the bottom. So 20, 30, 40, 50, 60, 70. And since we're not really starting at 0 here, let me put a little cut mark like that. Okay, and then the frequencies go up to 7. So maybe I'll do 1, 2, 3, 4, 5, 6, 7. And so now what I'm going to do, I'm not going to center the bars on the numbers because this is the 20, so it's going to go from 20 to 30, 30 to 40, and so on. So this first class has a frequency of 2, so it goes from 20 all the way up to, but not including 30. This would be 30, but all the way up to, but not including 40, 40. Now this one goes up to 7, all the way up to, but not including 50. And then 50 has 3. And then 60 has 1. Okay, so now we're not done yet unless we put on a title. And this is an interesting one. It takes a little thought to give it a title that's clear enough for someone to understand the graph. So you don't want to just put like home runs or Babe Ruth or something like that, but you're going to want to explain what the data is. So this is number of home runs hit by Babe Ruth, and even that's not enough. Hit by Babe Ruth when? So I would say each year of his 15-year career. Okay, so the number of home runs hit by Babe Ruth each year of his 15-year career. So down here would be number of home runs. And then this again is a little tricky. So the frequencies are actually counting. So when I have 7 here, that means 7 years of his career, or 2 years of his career, 3 years of his career. So here I'm going to want to put probably something like number of years of career. Okay, and now that makes it very clear what the data is showing. Now, if you're interested in the shape of the data, this is an interesting data set because like this, it's almost perfectly symmetrical. If I would take this one block here, this one observation, and move it one class over, it would be perfectly symmetrical. But there are other division of classes where you can get what looks a lot like a distribution that's kind of left skewed because he had a few 20s and 30s, but a lot of 40s, 50s, and then 160. So it's an interesting data set, but I would probably say for the most part it's roughly symmetrical. There's no real serious outliers, okay? So that is group frequency distributions for discrete data, and let's look at another one.